Hey, welcome to the Virtually Speaking podcast. My name is Pete Flecha, and joining me as usual is my good friend, Mr. John Nicholson. John, officially, Happy New Year. First episode of January. How are you, buddy?
I'm good, but I just had some food, and it was a bit bland.
I knew it.
Taste in my mouth. I thankfully have Dr. Pepper here to wash it out, but yeah. No, I mean, don't you just hate it when people don't season things correctly?
I do. And for those new to the show, welcome. John is the king of segues. I'm so thankful for that. Yeah, no, absolutely. Everything needs a little bit of seasoning. We're talking about a product that is, references seasoning, salt. Actually more than just a product. It's a technology. I really want to dive into actually, the SaltStack and sort of what it is. But yeah, we're talking about salt because for those that are not aware, John and I are actually we're getting ready to dive into an entire series starting next week on all the VCF advanced services. And there's quite a few. And some of them, I'm sure many of you would be familiar with, but others not so much. And so we thought, man, why don't we just peel the layers back on all the individual advanced services. But one of those actually is ACC. But there's a deeper part of ACC because it breaks down into multiple parts. And I thought this one might be interesting to actually dedicate an episode to just part of that, which is salt. It's a concept that I think, it's an automation tool that I think a lot of folks are familiar with. And so from a VCF perspective, it makes sense, to have that automation. We've got it with VCF automation. But what other tools are out there and what are their capabilities? So we are going to dive into what ACC is in the upcoming weeks as part of our advanced services series. But today we're going to talk specifically about a part of that, which is salt. And we're not alone. We're joined by a good friend of the show and actually a neighbor of John's in Austin, Mr. Vincent. Is it Riccio or Riccio?
Riccio, yep.
I should have known that as an Italian. That sounds very Italian. Riccio.
Yeah. You could say Riccio. Technically, you could say it and get away with it, but yeah.
Yeah, I know you guys are both in Austin.
Good to be here.
Yep, I know you guys are both in Austin. And every person that when I say, and I talk to them and I say, do you know John Nicholson? And they always go, oh, yeah, he's the guy with the bottle of Buffalo Trace sitting at his desk. So,
yeah.
So John, you're known well. But yeah,
the coffee needed some flavor, Pete. The coffee needed some flavor. So,
absolutely. So, Vincent, thanks for joining us. We do want to talk about we want to dive a little deeper on salt, specifically on the automation, what it does for VCF, where it fits. But maybe even before we go that deep, it's an automation tool. There's a lot of different choices out there for folks that are looking in some automation. There's Chef, Puppet, even Ansible, what exactly, how does SaltStack fit into that? And then maybe we can go into why is this the option of all the different automation tools? Why did we go with SaltStack?
Yeah. Great question. So, really what Salt gives us really two main areas of capabilities. And within each one of those, there's a number of subset of capabilities. So in this ecosystem of configuration management, state management, and so forth, I think Salt has always brought some unique capabilities in the market. And part of that is just being able to take advantage of some technologies they have, like event bus or remediation type of stuff. And we'll get into that. And so some folks know Salt just from hey, I need to run a script on a machine, do a couple things and manage my workloads. But there's also a whole other portion of it that comes with the ACC SKU that you mentioned. That also does a lot of compliance and vulnerability scanning or remediation there as well. So for CIS, so it's more than just, kind of like orchestration and deploying stuff. It's also part of a whole flow of getting that VM or that workload out there in a way that's secure, compliant with your not only regulatory agencies, but also with your company, as well as being able to do a lot of day two stuff. And I think that's really where it shines a lot of times is in the day two management, ensuring that those machines are in the state you want them to be in and that they, are not compromised in certain ways. So those are really kind of the two main areas, right? But ultimately, people use it because it's a very flexible product to just manage your workloads, to get, to just go into your operating system, deploy packages, ensure that, we have the machines in the right state that we want them in. And if it deviates from that, remediate it, and then also go run scans on it. So we have this whole SecOps flow that can be incorporated into the ultimate automation or into your automation flows and things like that. So really complements that type of workflow and initiative. And it's very flexible in terms of the scripting languages you can use, the modules you can build. It's a modular system. So these modules are written in Python. And so if customers go out and run a module, they can run a module, interact with their, the third-party components and stuff like that. So, and there's a pretty robust, obviously a robust open source, ecosystem out there and folks contributing and so forth. And then, of course, I handle a lot of the commercial side of the SaltStack portfolio as well, and our automation stuff as well. So there's always synergies there that we like to take advantage of. So hopefully that helps a little bit in that aspect.
So this architecture sounds awesome, like the speed and the scalability. But generally, when people start talking about speed and scalability, I generally start thinking like giant resource overhead. This thing's going to require, a VM with 128 gigs or something. What does my resource overhead look like for how I build and deploy and scale this out? Like, what does this need in my data center?
Yeah, good question. So, from the open source perspective, it's pretty minimal, right? And in fact, the minion agent is pretty small. It's a small agent, and the Salt Masters, you're generally just going to run those on, fairly smaller Linux boxes, depending upon the workload amount you're going to have. So we do have some sizing like guidelines and stuff in the docs. Like if you're going to have 5,000 minions, and we recommend so many Salt Masters. And those can generally be, fairly, reasonably sized. They don't have to be large, 128 gig machines or anything like that. So you'll have those Salt Masters sitting out there, which should be relatively, small or, not overly large. The VMware Salt appliance itself, or the machine itself, can be sized appropriately depending upon the workloads. So, like for instance, in our labs, we get away with doing things with like, maybe like 4 CPUs. 32 gigs of RAM, and then I put like maybe 128 gigs of storage on it. Now in production, it depends on how they architect it. So there's two ways that you can use the VMware Salt. You can use the VMware Salt UI machine as your Salt master, and then have everybody report up to that. If you do that, obviously then that would need to be a little bit more beefy. But the way that they generally do it in most production environments, where they're really going to use it, they really have a large environment, they are only really using that VMware Salt UI as a UI into the environment. So it's just that database within the Salt UI, Salt system that's going to get big. There's a Postgres database that could fill up, or that could require some storage, maybe 500 gigs or something, depending upon how many VMs or minions and workloads you're going to have. So from a throughput perspective and performance perspective, you just want to scale it appropriately. If you only have 1,000 minions, right, you can get away with a pretty small infrastructure because everything's pretty efficient in how they deal with things. If you have 50,000 minions, then yeah, you might need a little bit more. So it's really going to just kind of depend on.
Is every device that basically Salt is touching as a minion, or do you have minions that then are also managing other things?
Yeah, good question. So most of the time, your minions are directly talking. They are the workload you're managing. So they'll be like your file servers, your database servers, your Windows servers, et cetera. But we do have some technologies within Salt where you can do something like a proxy minion. And so you can actually install the minion agent on a machine and use it as a proxy to actually talk to something else that you can't put the minion on. So there's
like
some devices
I can't install. It does have an IP address,
right,
but I can't install
right.
it. So I could have it go query that, or my switch, or whatever that is.
Yeah, potentially, yeah. So and a lot of these cases are switches or routers. So because we can't put the minion on it, we can actually create a proxy minion. And there is actually some Cisco and a couple of other switch vendor modules out there that could potentially be used along with that. So and in fact, we did that at VMware. The VMware IT folks transitioned over to Salt. They use proxy minions to manage backups of all of their Cisco switches, and so yeah, it can be done that way.
When you speak of all these minions, do you think of do you think of the movie or like?
Yes. Yeah, for
Okay, I'm
sure. In
just.
fact,
Is it
yeah.
just me? Because every time you say
No,
minions,
no,
I
I
hear
do.
the little.
Yeah, yeah,
Little
for
yellow
sure. And in
guy
fact,
who's like flying
yeah,
a
little yellow
plane
guy.
incorrectly.
Yeah, and in fact,
Okay.
I've got little minion stress toy like that I've got at Salt conferences before, just like in my house, in my office here and stuff. So yeah,
Okay.
definitely minion.
Just to be
We've
clear,
just
you
never
have to
figured
be
out.
Gru for Halloween. Like you don't have
Yeah,
a
that's
choice
right.
in this.
Well, we thought about trying to figure out how we can use Gru somewhere and name something else Gru, but we just haven't gotten there yet. And plus, we're a little worried about uh, copyright. So
I have so
Yeah.
many comments. Obviously the minions, right? But also like I thought we weren't allowed to say master anymore in 2026.
yeah, that's another
My
thing.
bedroom is
Yeah,
a primary bedroom, and now we're talking about salt masters and
that's
minions.
right.
I mean, where are we?
Yeah. Yeah, that's right. Yeah, we've gone through that a little bit with corporate, and so yeah, it's not going to change apparently because it's so embedded in the product.
Yeah, no, I
But
mean it's an open
yeah,
source product. Like that is part of what it is. Yeah, you see it everywhere for sure.
yeah,
Okay.
yeah,
So yeah, let's talk a little bit more about like what this looks like. I know we're looking for those listening. We're gonna share links to content on the show notes of the page. But for those watching the video on the YouTube video here, we've got some slides. So maybe we can walk through some of the architecture and maybe even the communication between the various components. I think that would be helpful.
sure. Yeah, so the communication actually, there's a couple of ways we can actually do the communication. In order to take advantage of the full functionality of the product, you'll want to probably have the Salt Minion agent on the machine. And that provides the ability to take advantage of the event bus, which will give us some other capabilities that we'll talk about. But that also allows you to do a lot of stuff with the machines very, very quickly. There is also an SSH option. So if folks are agent averse or they don't want to open up the port, they can also SSH into the machine using an SSH kind of roster. So they can do that, but you will miss out on some of the capabilities like that the event bus brings. So essentially, what happens here is that a job gets created. You have an admin that says, "Hey, I want to run, a script against a certain minion," and then that actually goes to that kind of gets cached on like the saltmaster itself. And then what happens is the minions are constantly asking the salt masters, "Hey, do you have a job for me? Do you have a job for me? Do you have a job for me?" And that just allows us to say, okay, we're not going to actually allow anyone to go directly talk to those minions. The minions are talking to the salt infrastructure, whether it's VMware Salt or whatever, and asking for a job. And so that also gives us another little bit of a level of security, plus
Yeah,
that
yeah. Because the push
communication.
system is always scared me to where, oh, I've got this one server that is a panopticon that has SSH outbound into every server. It's
Yeah,
like when the security auditor comes up to you and is like, hey, can you open SSH on the ESXi host and give me the root credentials so I can audit them? And I'm like, what? What? He's like, well, I'm going to fail you on the audit if you don't give me root and you open SSH for me. And it's like, what?
yeah,
What? No, bad, bad. Like this
yeah.
pull system. Yeah, that sounds like a much better system. And also from a network design and everything else, it sounds like it'll be much more coherent and scalable.
Yeah, and two, anytime you have kind of sort of a technology or something that's where you have that constant communication like that, there's also hardening things and stuff that you may want to do. So in the documentation, we do talk a little, we do have some hardening guides and some security, yeah, maybe suggestions like if you want to run things as non-root or if you want to have a dedicated user to run all these commands and stuff like that. So there's definitely some things that we've done to make it, a little less scary in that sense.
The
But
minion can have limited context of what it can run. So even if it gets a job that is problematic, the local user account was restricted from doing anything terribly bad.
Right, right. Yeah. And once it creates that communication, so the other interesting thing about all this is that when that minion establishes communication, uh, you actually have to accept the key. So generally out of the box, someone actually has to go and accept that that minion is valid and can receive the jobs. They can automate that if they want to, based on certain criteria and stuff like that. But generally there's someone there accepting the key, and then we actually have an AES and RSA encryption, kind of security stuff there that happens. So there's secure communication happening between the two, and uh, and then there's also other like levels of security within there. So you can put some more sensitive data for your machines, like in something we call Pillar. and Pillar will actually encrypt the data even further and stuff like that. So you have to think a little bit about overhead with some of these things, but at the end of the day, it does provide some capabilities for customers that may be very sensitive about stuff like that.
Okay. Well, you said at the top of the conversation that one of the big values of this, and one of the reasons VMware and specifically ACC is using it, is for drift remediation. So maybe we can talk about what that looks like, and how does it do that? Is it only report drift, or how does it react when there is drift? Maybe we can walk through some of that.
Yeah, it'd be great. Yeah, so this is really kind of like one of the highlights of the product, I think, and something that's been very helpful for our customers, and is actually a fun part of the product actually to kind of play around with. So there's kind of this concept, or there is a concept in Salt called reactor beacon, and that takes advantage of that event bus. So because we have all these events going on, we can actually pull some of those events out and say, okay, what do we want to do when a certain event occurs? So the reactor beacon system is really just a set of files. You have a reactor file on your Salt master, and you have the minion agents that also will have a beacon file. And what's nice also about the VMware Salt UI is you can push all those files down to all your machines, so they have them. But if we look at the right on the Salt minion, we'll have a beacon file there. And what the beacon's doing is it's looking for some event. So a customer can say, hey, I want to look for, if cron service stops, or I want to look for, like, let's say a file change, or I want to look for, let's say a firewall port gets open, or just something like that. Then that beacon will go, hey, that happened. The cron service has stopped. So what that does is it throws it up on the event bus. Well, what the reactor file is looking for is an event that says the cron service has stopped. So the event will be in a certain kind of format. So we can tell the reactor, hey, look for that. And when that happens, I want you to run this script. So we tell the reactor, okay, when you see that event come across, then I want you to do these other things, which is really what we call the reactor files, these reactor state files, because the reactor state files are trying to get the system back into the state that we want it to be in. Salt is very much about maintaining the state of the system, whether it's manual or non-manual or automatic. But the nice thing about this type of reactor beacon situation is there's no manual intervention. Users don't need to do anything, or admins don't need to do anything. It's going to automatically do it. So it'll run that script, and it'll get maybe restart the service, right? Or it could reboot the machine, or close that
Or
firewall
reapply the
port,
config file,
or reapply,
assuming like
reapply a
a
file.
firewall config or something's been borked, or some type
Right.
of reassert security compliance of, okay, somebody tried to update the PF config, like let's slap that right back on.
Yeah, exactly. Yeah, and we actually when we first acquired Salt, one of the demos we immediately built was we used our coastering technology at the time to deploy a VM, and we actually had a script that would hack, like we would deploy a VM, and then we deployed our OpenCart like website on it. And so we had this website on it, and we would push a hack down to the PHP file, and we'd mess up Nginx, and it would show, hey, your site has been hacked. Well, what we did was we had a beacon on there that was looking for that file. If that file ever got changed, then the file that we wanted it, the text and everything that we wanted to have was already in our file server inside of VMware Salt. So all we had to do was just push that file down using the file module. So we would tell it, okay, the file is located in this directory inside of Salt. Push it down to this directory, like your var or whatever, www, folder on the machine, and then replace it, and then restart Apache, right? So we had that happen. So we were simulating a hack basically, and that was really nice because it happens actually really, really quick. It's like a second, right? So as soon as it changed it, we actually had to put a sleep timer in there just so we could show people that the site actually got hacked, and so forth. So we had a little fun with that. So, but that's kind of the idea of it, right? Is that the reactor beacon system takes advantage of that event bus and does more of that event-driven self-healing, fully automated remediation. And the beacon modules, there's a number of them out there that are already published and written, but customers could potentially write their own as well. But yeah, this is definitely a cool feature of the product.
Yeah. So are they writing their own? Are they writing their own states, if you will, or is this something that is provided? How does that work?
Yeah, good question. So it depends. A couple ways that they can go about it. Depends on what they want to change. There are some examples out there. So in fact, there's actually a site out on Git called Salt Formulas. Salt formulas are essentially a number of state files that have been created by the community, and then people publish them to a repo. And Solid is a pretty strong community, so there's a number of state files already out there. So let's say you want to deploy Nginx or something like that, then someone's already done it. They have a bunch of examples. You can pull them down. Now for the reactor beacon stuff, you might have to create a custom state file to actually get it back where you want it to be. But it's pretty simple. What's nice about the state files within the Solid product is not just that they manage the state or they're idempotent or whatever, but they can be written actually in multiple scripting languages. You can do YAML, Python, JSON. So it really gives folks flexibility in how they want to write the state. And then these files, like you have here in the slide, these are declarative YAMLs, state files that essentially will be used to configure the machine. Now, if you notice some of the text in there, it'll say things like, the module itself is file managed, right? So file, if you look at index file, what we're doing here is we're pushing a file down to the machine. So that file managed and that service running are what we call modules and functions. And they're sort of in a past tense, right? Or current, like we want it to be managed, not file manage as doing a remote execution command, but more managed. So if it's not there, put it there. If it's there, just kind of move on. Or if it is there, make sure it's in the way that we want it. So that's really kind of the power of these. And you can tie these state files together and create a whole orchestration. So if you have multi-tier apps and so forth, you can tie a lot of these together. And you can also call like other types of scripts. You can call like pure Python scripts if you want, or just a bash script. Let's say my file manages a bash script here. It's an index.html file. Those could live just in my VMware Salt, UI, and I just call them, right? So you can really manage a lot of your whole scripts. That's what I do actually. I just manage all my scripts I'm going to need for my VM in there, and then I just call them using the file manage. So it does make it really nice system to be able to really take advantage of that sort of idempotency, I guess, if that makes sense.
Yeah, I like the way this is. This is not just reporting, right? I mean, this is you're verifying compliance, and so you can actually have that level of awareness, but also remediation, right? So if anything is changed, you've got the ability to monitor that. Is that a big deal for a lot of customers out there? Is that a big need to have that large scale compliance, or?
Yeah, I think so. I think it's really nice for folks to be able to say, hey, if the system drifts, especially a very particular thing that might be detrimental to them or something, or more catastrophic, then they can do it. And it may be just certain workloads that they use that reactor beacon on, right? Things that are a little more critical and so forth. But yeah, I think it's something that really resonates with our customers, because it is so hands off as well, especially after you've got everything set up. But like the slide you have here is taking it actually to even another level. Which I think this might even resonate more with folks when we talk to customers, because really doing that compliance and vulnerability management scanning is really, really helpful. So we actually manage a repo of CIS and DISA type of benchmarks and checks. And then for vulnerability, we have a repo for vulnerabilities for the CVEs and all that kind of stuff. And then we reach out to these CIS benchmark sites and stuff like that. So essentially, we have two areas. We can run compliance checks against these minions to look for violations against a number of benchmarks for operating systems across Linux, Windows, all kinds of stuff. And there's, like for instance, I use an Ubuntu 24 or 22 compliance scan that I run occasionally on my Ubuntu machines, and there's like 300 checks in there. Everything from SSH max config all 3 tries, to all kinds of different stuff. And so if it goes out of the config that we want it to be in, like for instance, if max all 3 tries should be 2, but it's set to 10 on the machine, it'll report that as a violation. And when it reports that as a violation, we'll see that in a report, and then we can choose to remediate it or ignore it, right? So it just kind of depends on what we want to do with it. But the compliance check does allow you to do that, and so that's been a really nice feature for our customers to kind of maintain the overall security posture of the machine, and especially in the SecOps type of workflow for most of our IT admins. And then there's the vulnerability side, which are CVEs that we look for with like Windows and Linux. So for instance, Windows, you could do your patching with this. It will connect to your, you put the minion on a Windows machine, and then it will go and look for updates, just like Windows updates. And it will, for instance, like I've got Windows machines that are running my lab. If I go run a WSUS update on it, and I can see, all the patches and stuff it wants to apply to the machine. If I go run it from here, I can see the same thing. But the difference is from here, I can remediate it just right from this tool. So it keeps me from having to log in the machines and stuff like that. And I've actually, I mean, I know a lot of customers have automated this using Microsoft tools, but we have also had customers use this in lieu sometimes of that, depending upon the workflow and if they want to use Salt for other things. So let's say, for instance, they deploy a VM, they run a high state on the VM to make sure it's in the proper state. They put the beacon on it to, watch a certain service ongoing. And then they might run a scan against it, right? Or run that patching ongoing using that running the scans. So it really gives you a nice complete workflow there.
Devil's advocate, why wouldn't I just use WSUS?
You could, right? I mean, you could just use WSUS. Some folks do like this a little bit nicer too, because sometimes you can actually write your own. There's actually a module for Windows patches as well that you can create here. So you could write a script that maybe sort of maintains a state or goes out and checks for it. So it's really just another way to inject those type of things into your workflow. Now the other thing is we can inject scans from other tools, and also they're using that underlying Salt technology and state files to do that. So doing that sometimes can give them a lot of visibility into what these patches are doing, because they can actually go and get some activity tracking and stuff like that. So I'm not saying this is something to go out and replace your WSUS with today, but it is
I mean, I
something
want
that
to.
you can,
I always hated the database cleanups on it, but yeah.
Well, yeah, and there's
Yeah.
pain points there too. That sometimes that could be a reason, but what
Yeah.
we find is that customers will have a workflow where they might deploy, do the initial configuration, and then run their scans ongoing, and then they have it all in one place.
It's funny. This takes me back to my early days as a Windows admin, and I won't tell you what year because it'll date me. But just the technology might even give a clue. But yeah, one of the first scripts I ever wrote was a program that would actually check my Windows print server, because the print server just kept failing. It would always fail. It would always stop. And you'd have these print jobs running for this company I worked at that were so critical and time sensitive, and so we would basically just wrote a script that would check the print server constantly because it would fail, and then it would have to restart the print server.
Minion on your print server.
You need a proxy minion. You can show if you had a proxy minion. It was easier, right? Yeah.
Absolutely.
Well, you know what? Also, too, just speaking of Windows, a lot of people think of Salt and they think Linux, right? And Salt actually does have a pretty robust Windows capabilities and modules. In fact, they have a whole what they call a Win repo, and you download a bunch of state files that will install packages for you and all kinds of Windows apps and stuff like that. In fact, there was one time I did it, and I had 20 apps just showed up on my desktop of a Windows machine because I just pushed them all down. So there's some cool stuff like that for Windows too. So in fact, there's an individual that works here at the company who's real Windows admin, and was doing a bunch of stuff with PowerShell and Salt for a long time, and just really had a lot of luck with it.
What I think how Salt was originally introduced to me was someone who was using it with Windows primarily, and they were doing desktop management. And what they did is they had perpetually, I don't know, just been jaded to issues with group policy replication.
Yeah. Those are
And
good
group
policy
policies
modules.
actually, it's pretty cool. The stuff knobs you can turn with it, but like managing replication and then getting status and stuff,
Yeah.
and getting an RSOP from the local machine to result in set of policy figured out. And he's like, you know what? Everything is gonna be enforced by local policy because local policy always wins, and GPO. And I'm just gonna deliver the local policies using Salt and tell it to enforce and keep enforcing.
Yeah.
And it's gonna check and do RSOP and validate. And if it doesn't come back, give me an alert. And because that was the big problem with GPO is great until it doesn't work, and then you have to figure out why, and you're like, oh god, this is 2 weeks of hell. But they basically just hacked around it with Salt. So
One of the demos I do actually is I have a bunch of local policy configs in a state file, like password length, password age, a bunch of stuff like that. And then I just say, okay, I want that password age to be 60 days. And then you just push that down the machine. So if you have, 1,000 Windows servers out there, you can just maintain that state all the time. Just run those high states and just make sure, it's in the state you want. But there is a whole group policy module thing in Salt. So it is pretty nice.
Yeah, that could be helpful. I'm thinking like with VDI golden master creation, where your golden image, like you're just to have the salt there and use it. Because if you've ever got a situation where like someone didn't back that up and you lost, and you're like, what all weird knobs do we turn to make these users happy? Yeah. All right.
like
Enough using.
No, I love it. This is
places I'm going to use salt in my daily life. So
it'd be great to have a user happy module, make everybody happy module. Right?
Yeah, absolutely. Very cool. Yeah. So, great stuff. I'm so glad that we did this one before we actually did our ACC episode. I think we're going to, because that one's it's going to cover the whole spectrum, but I don't think it would have been able to walk through this level of detail. So, man, Vincent, very cool stuff. First time on the podcast, hopefully not the last.
Yeah, hopefully not.
Yeah. Thanks for joining us, my friend. Enjoy the rest of your week.
Yeah, thanks. Anytime.